got it. Bienvenue.
Oh, is that it? Okay.
Sounds like kidding.
Yeah. Jacques Leblé. Les poissons, les poissons. Les poissons. Such a sweet little succulent crab. All right.
We're gonna get banned for hate speech.
I know, right? What? That means Little Mermaid is hate speech then.
The Little Mermaid is amazing.
I know. Anyway. All right. Okay. Okay. Let's pretend like we're doing math now. Okay. So I'm gonna pretend, and I'm gonna skip a couple things because it's actually not on the exam. That's why I was actually struggling with this. I'm like, what the hell? Yesterday, and so I'm gonna pretend like yesterday didn't happen because it was measuring error, and that actually wasn't. This isn't a topic that's covered on the AP exam. Newton's method isn't actually on the AP exam, but it is going to be a good thing. I don't know why it's not on the AP, but it's supposed to be there or not. I don't know. Anyway, all right. So okay. So finding differential function, interpret geometrically. This is the one that don't worry about because you're measuring, how far off you are going to be when you're approximating this. Approximation again, blah blah blah. Don't worry. Okay. Hey, look, it's all worked out here. Anyway, so right here, the formula that we're going to be using for finding a linear approximation to a function is this thing down here. Okay. So it's going to work out. So you get the linear approximation is going to be equal to, so another way of writing this, it would be L of x to signify that this is going to be the linear approximation. So it's kind of like we're finding the approximation at a number that we don't know. So kind of like we're taking a derivative at like 2.5 or 2.1 when we know the derivative. We know the value at 2, but we don't know at 2.1. Does that make sense? Yeah, so we're going to do an approximation of this. All right, so then it says f of sub naught, which is the initial that's going in there, right? And the derivative of f sub naught, which is the point, again, and then it's going to be x minus this. So it's actually like equation of a slope formula, where we're actually going to get like the y is equal to this or that. So there it is again. Okay, so L of x, this basically is just the equation of the line. AP exam insight on the exam, the term local linearity is sometimes used instead of linear approximation. Okay. All right. So this is going to be important. All right. So now we're going to do this right here. So find it right here for when it's going to be x is going to be near 0. So x is going to be the point that I'm looking for. That's going to be my sub naught right there. So if I'm going to write it out, it's going to be L of x, right? L of x equals, now what the function say that goes next?
F of x sub naught.
F of x sub naught, which is going to be f of x. So it's going to be sine of 0. What is sine at 0? 0. What goes next? Plus the derivative at that point, right?
Yeah.
Plus the derivative. Now, what's the derivative of sine? Cosine. What's cosine at 0? 1. So I'm going to have 1 parentheses. And it's going to be x minus x sub naught, which is my original, right? My x that I'm plugging in. So it's going to be 0 right there. So I do all the math and I come up with what? So linear approximation, there. Yeah. Okay, so we're going to do the same thing again for these other values. Okay, so you're going to use your calculator on these because these ones right here are going to be decimals and stuff. Right? Say yes. Yeah. Okay, so now for this one, it's going to be, actually, let me see. 3, 1, 4, 5. No. Okay. So first one is going to be L of what was it? 0.3? Negative 0.3 equals, that's going to be sine of negative 0.3 plus cosine of negative 0.3 times x minus negative 0.3, right? So just plugging it all in. And when you pick up that calculator, what's the first thing you have to make sure you do? Make sure it's not in degrees. I know you guys didn't do it, did you?
Yeah, no, I hate it because it's always in there.
Do you know why? Because my trig classes are degrees, and guess what? They're 7th and 8th hour, so they change it all to degrees, and if no one changes it during first hour, that means you people. They didn't use calculators today. Speaking of that, test corrections tomorrow, if anyone want to volunteer for helping out, tutoring, okay, because they have to do the test corrections tomorrow. So, advisory, yeah.
No advisory.
Oh crap, there's no advisory tomorrow. You're right, I'll save it for,
Monday.
no, there is on Monday. There is travel because Monday's the end of the 9 weeks. Or not Monday, but next week is. Yeah. So, okay, so Monday then, all right? So as many volunteers as I can, I do give you guys credit. All right, what did we come up here? So it should be it should be ugly, right? Whole bunch of decimals everywhere. Anyone? 0.295?
0.296.
296.
And point
Plus?
plus 0.955.
Is there an X here?
Oh yeah. And then times 0.3, which would be 0.286 or 0.287.
Plus?
Yeah, plus 0.287.
Okay, and what do I have to do with my values?
Wait, it's negative
Yeah,
point
it's
two nine six.
negative.
Yeah, that's what that-
296.
Oh, it's negative right here?
Yeah.
Okay, thank you, yeah. I knew one of the signs had to be off because, yeah, anyway.
Combine like terms.
Combine like terms, so what do we come up with? Should be a negative, right?
Yes.
Negative what?
Negative 0.009.
0.003.
009 plus 0.955x, right? There's a linear approximation for there. Okay, so what was the next one to do? 0.1? Okay.
Oh man, I think we get the gist.
I know.
Yeah.
Can I jump to
Jump
sine
the-
pi over
Yeah, I
4?
was gonna say, can we jump to the one where we don't have
I know. Let's jump to pi over 4. I like that one. Okay, so let me see. Sine at pi over 4 is going to be
the rad 2 over 2, right? Yep.
okay, and plus
Same thing.
rad 2 over 2 quantity x minus rad 2 wait, no, pi over 4.
Yeah.
I was getting all excited with my rad 2's over 2's. All right, so really not going to do much because I'm not going to be able to combine those together. And minus yeah, can't really combine them because it's going to be pi plus, yeah, no. Yep, that one's not gonna do. Anyway, all right. Yes, are we okay? Are we happy?
Yeah.
Okay, good. All right, so now time to make you unhappy. A spherical bearing has a radius of 3 centimeters when it's new. Use differentials to approximate the volume of a metal lost after bearing wears down to a radius of this. Find the actual volume lost compared to the approximation to the actual volume lost. Okay, so now this is kind of what we were working on yesterday, but we were just looking at the error part of it, and we don't need all that. So what we're looking for is actually the dy dx is equal to, now, we're looking for a volume, right?
Yes.
Okay, what shape is that?
I think it's
Cylinder.
Sphere, right?
sphere.
Right? Yeah, because it's a metal bearing, bearings around, it's a sphere. So what is it going to be here?
Depends on, are they shaped or?
Is it what?
I was naming the brand of this sugar bear.
Okay.
Yeah, they're not
There-
very specific.
I know, right? There's Spitfire.
I like shaped up.
Oh, I'm sorry. You know, not everyone could actually ride good bearings then. All right, so let's take a look. We're gonna have 4/3 pi r cubed, right?
Yeah.
Yeah.
Okay, so now we're gonna try and do this because we're gonna have a change right here, right? This is gonna be the change in r, isn't it? So this should be like a dv. So this is dv, and this is a dr, right? So we're talking about the volume, so that's why it's dv, and dr is what we're actually going to be integrating or deriving for. Sorry. All right. So right here, I'm going to go ahead and do this, but then let's actually move this to the other side. Because right now I only have the volume formula is 4/3 pi r cubed, and I'm trying to find this and how it changes. So it's going to be, let me see, 4 pi r squared. Now I want to, and this represents the dr represents the change in r, right?
Yes.
Okay, that represents a change in r. So I'm going to move this to the other side. So dv is equal to 4 pi r squared dr. Now, okay, let's take that information. Do I have another slide that I could use? No. Okay, so I'm gonna take this to a new slide because I need some more scratch paper. So I said dv equals 4 pi r squared dr. Now, first, what is the radius that I'm starting with? 3, right? So my radius is 3, so that's good. What is the ending radius? What happened after this crappy bearings, wore out a little bit? So it's going to be, it's going to end up at 2, so 0.971, right?
Yep.
Okay. So now, what did I say that this dr stands for?
It's the change in R. So
The change in r, right?
difference.
So what would I do to get the change of r here?
Subtract.
Very good. Subtract those two.
Yes.
It's like
Yes.
0.029, right?
Yeah.
Yes.
Okay, so that we know that my dr is going to be 0.029. Yeah?
Yeah.
Okay, so now we're going to go ahead and put this in for this. So now we know that the r is 3. My dr is,
0.029.
okay, so I have dv is equal to 4 pi 3 squared 0.029. What is it? Point what?
1.044 pi. I believe.
No, multiply by pi. I need that.
Oh.
Oh wait, hold on. There's one more thing. Since it is going down, I need to say that it's going down. Sorry. But it is. We would still talk about that as it's going down. But I want to show it mathematically that it's going down. Because if it was increasing, it would be a positive number. But since it's decreasing, it's going down. Okay, so actually, did you multiply the pi?
Yeah, but hold on. Since it's negative, I'm gonna read.
It should be negative.
It'll be the same.
Because
Yeah,
you're
negative
it's the same thing.
3.28.
Okay, so negative 3.28. Now, was there any more after that, or is it just that?
There is
Negative
3.2798.
798. Okay, 2798. So 2798. So that's going to be an 80, right? Now, what are my units on this? What is it? Centimeters cubed, right? Yes?
Yes.
Okay, centimeters cubed on this. That's important to actually talk about what it is. So now, can someone tell me what is this actually saying? Yeah, so the change in volume, right? So we're actually finding an equation. So we're doing an approximation for the change in this. Okay, this is just the approximation here. Now, let's take a look at this and actually see what the actual change is. So we're approximating, and that's what all this was. Okay, that we're approximating the change that we're going to have. But now let's do the actual change. So the actual change would be, so it's going to be V of 3 minus V of 2.971. So remember, this is the approximate. This is the approximate right here. That is decreasing that much. So this is another calculator one, right? Because I know everyone's pushing buttons right now frantically.
Yes.
Yes, right. Remember, calculators are your friends, not food.
Oh, what?
Are you Netflixing right now? Bruh. I just have to calculate it. He's really trying to Netflix right now. Man, can you believe him?
What show is he watching?
It's a weird show, probably.
Okay, what do we get? So first, what's V of 3? 113. Point
097.
minus, it's like 109 something.
Say it longer.
It's like 109 something, I don't know.
You said 110.505.
No, 1.92.
What is it?
1.92.
Oh, 110.92.
The only problem with the approximation is like 2/3. I mean, greater. Like
Okay, so what do we get for the actual loss?
Negative 3.248.
For the actual loss, we're losing that much, right? So it's approximation, it's close, right? Because we approximate it, that's whenever we're approximating. We expect it to be close, but not exactly. Does that make sense? Hopefully? Okay. All right. Error. Nope, not the error. Okay, Newton's method. Okay, suppose the function is defined on a closed interval a to b, and its first derivative, f prime, is continuous and not equal to 0 on the open interval from there to there. Okay, if c1 is sufficiently close, first approximation to a real 0 of the function f in a to b, then the formula c2 is equal to c1 minus f of c over f prime of c. So it's the function at that point minus f prime of c. So the derivative at that point. The second approximation to the 0 then the nth approximation to 0 is there. Okay, so now if you notice, we keep going to find the next number for each one of these. Okay, it keeps going in. So we're actually trying to find as close to a 0 as we can without actually getting the 0. All right, so now we're using that right there. So let's take a look. Newton method to find a fourth approximation to the positive real 0 of the function. Okay, so now first, what do we want to use? Okay, it said you close interval, right?
Yeah.
We're trying to find a 0. Okay, this is the intermediate value theorem. Intermediate value theorem says that there should be a 0 somewhere in between my endpoints, right? Okay, so let me see. Let's see. Let's start off with let's go 1 and 2. Okay, if my A and B is 1 and 2, I'm just guessing at it just because of the small. So it'd be 1 and 2. So my intermediate value theorem says that somewhere in there, if they change signs, then what? There's going to be a 0 in there, right?
Yeah.
Okay, remember chicken crossing the road. Okay, if it changes size somewhere there, then it has to cross. So let's go ahead, plug that in. So it's going to be 1 plus 1 minus 1 minus 2. What's that give me? So f of 1 is negative 1. Okay, so it's negative. That's a start. What's f of 2? I'm telling you, that cricket's been killing me here. 12? 8 plus 4 minus 2 minus 2. Okay, so what does that mean now? It means that there's a 0 somewhere between 1 and 2. Okay? So now, let's take a look. Let's start off with a number. Okay, I know it's going to be closer to which one?
1.
It's going to be closer to 1, isn't it?
Yeah.
Okay, so let's say 1.2. Okay, let's try 1.2. So if I go back a page and I say here, C1, right? So let's go ahead and for this one, it's going to be, for this, it's closer to that one, so I'm going to plug in. Let's try 1.2 right there. So it would be f of 1.2, right? Minus f of 1.2 over the f prime of 1.2.
Wait, why does
Look at the separation in between -1 and 8. Which one's closer to 0? Yeah. So it's going to be right here. Find a fourth approximation to the positive real 0 of the function. So it's a positive. What do we get?
I got negative.
You got negative.
Yeah.
Okay. So, is that right?
Yeah.
Okay, everyone, if you got a negative, is that where I'm supposed to be?
No.
No, it's got to be
Higher.
positive, right?
Yeah.
Okay, because it says fourth approximation to a positive real 0 of the function. Okay, so let's get us a positive. So that's too much. Let's try right in the middle then. So let's try f of 1.5 minus f of 1.5 over f prime of. So if you have calculators, that's the easiest way to actually do this. And you don't have to plug it in every single time.
You just graph it and then let the
And var it.
you var it, yeah.
You said graph it and var it?
Yeah. Could that not work?
Yeah, it does.
Okay.
That's what I'm asking.
Hey, Mr.
Yeah.
Pancho,
Yeah.
Alex found a mistake.
He found a mistake.
He's about to tell you.
Oh, what's a mistake?
Yeah, it's supposed to be 1.2 minus f of 1.2 over f prime of 1.
Instead of the function value for the C.
It should be f of c, right?
No, to the left of that, C1.
Oh, c1, you're right.
Because we're going to the fourth.
Dang.
Candy time.
I know, right? Dang. All right. Is that you, Alex?
Oh, I didn't see that. Rip. Did I get a rip in the chat?
That messed up our first one?
Why don't we just look at it?
I have got positive.
Yeah, positive 2? For this one, the 1.2? So this gives me a positive 2.
No,
Or 1.5 gives me a positive 2.
Where are you getting Q from?
no, it's not two, it's positive.
You literally should have said I got positive.
Just a, no, he meant like TOO.
No, I said I have gotten a positive, and she said.
On which one, 1.2?
Yes.
Okay, so it's a positive. All right, that's a good start then. So this is a positive, right? Ah! I erased it instead of, okay. Okay, so this is going to be a positive. What do we get for a positive? Give me the number.
1.205.
0.205.
6.
6?
Yeah,
I mean, you can round it up.
Well, yeah, it's supposed to be.
There we go. Okay, so now, that's positive, isn't it?
Yes.
Okay, let's try and get it closer now. Okay, now we're trying to get closer. So now, what goes in next? Yep. So it's going to be 1 point.
I know. Are we doing this 4 times?
Yes.
Thought so.
Because the formula, every time, to get the next one, I put in the previous one.
Yep.
All right, what'd we get?
Yes.
One point, one point 206. Wait. Yeah. Oh, it's like really, what was that saying? Ooh.
Did you do it? Just plug this one in.
Yes.
Yes.
1.20.
This one's 5 now?
Well, it's 5.5, so it's still.
5.5.
It's still a 6 then, right?
Yeah.
Okay. Okay.
So do we keep going?
Okay. Now, hey, look, we're going to have. Okay, what do you think is going to happen every time now?
They're gonna get closer and closer to 1.206.
Yeah, it's, but if we're plugging in 1.206, now, let's go back to the first one. Okay, if I put in more decimals, do you think it would change this?
Yes.
Yes, because it was off by a little bit, right? It was off by a little bit, it barely rounded up to that. Okay, so now for this right here, so what was my first one? Give me a couple more decimals on the first one.
1.2055.
Okay, 205, 5, 9, 9, 4. Okay, let's try that.
It was 9.4.
94.
I didn't get that either. I got 1.205569. So I didn't get
Huh?
that.
6, no.
That's because I'm just using bar. So like I'm using the graph of the derivative and then the graph of the original.
Yeah,
I'm just plugging it in straight.
9.44.
What do
But
you-
whatever, we're
I
gonna
think-
use that
I think-
number.
I think you're looking at the 1.206.
I think, what do you think?
206. 1.2. Oh, okay. Well, so.
It's supposed to be 1.9.
Oh wait. What are we on?
There's actually
Can we go back?
Is there too many 9s?
1.9 and 2.4.
1 9 and 2 4s, I'm sorry. So now as we do this, as we're getting to this,
What if I enter this as an X with an X? And then it's like that. Can I copy? Should be with something highlighted. So that copy is the graph and then bars the entire thing. You know the copy? Entire section.
Here. And then I don't know how to
So
read
wait.
it.
Control C. No, it's gonna work.
did you get the next one?
The 1.206.
Is it 6 on this next one?
It's the same
Wait,
thing.
which Which?
We're changing this one. So the first one,
The
so-
1.2.
yeah.
It's 1.20559440.
Okay, now plug that one into the next one.
Gotta use all that.
406. Is that what they said? It's the number that we're using.
I don't think.
You want us to just keep plugging it in?
Okay, so I have to do it how many times?
4.
Yep. Now, you guys are gonna be very, very upset with me.
Yes, you
And I'm gonna show you guys why.
Summation.
For what?
Do this, or we're just plugging it in.
Just do the
No, I mean like. I know, like, but like, we're gonna do some easy ways.
Oh no, yeah. Go get erase it. Erase what the numbers inside. Just press control, the negative.
Oh, yeah.
Control.
Yeah, let's play it.
So was the 1.2 the first time?
Yeah, 1.2 was the first one, and this goes out, right? And this is what we got out of it, and this goes into the next one. And you just keep doing it until you get closer and closer.
You have to subtract it by the same number.
Oh, yeah.
Oh,
Pressing the wrong button, dang it.
Okay.
The number's barely moving.
Yeah.
Is it pause, mister?
Hmm?
Is it paused?
No.
Oh.
but this video's gonna go.
Yeah, it's gonna be long, but this is actually the point. Now, the whole reason why you're trying to do this is you keep plugging in. So this is supposed to be like an algebraic way to actually figure out where a 0 is when it is a real number, but it's like some strange radicals. It's the exact same thing as finding the 0 right here.
Should we not just do that?
That's what I was saying. You guys would be mad at me when you find out why it's 4. Just to find the 0, where this point right here is going to be 0.
Oh my god.
So as you keep plugging in more and more, you get closer and closer to this number.
Dude, I think I'm on that number.
Are you?
I've been on that number for a while. It's just the same number over and over and over again.
And just
The calculator literally just says, dude, it's there.
It's just-
Yeah. It's been like a couple times where the number's just all there.
Okay.
they just keep adding another decimal.
Yeah, we started at 1.2. We started at 1.2 because it looked like it was closer. If we started at 1.5, you would see more change.
Oh, yeah. That makes sense. Because
Yeah.
like changing like barely anything.
Yeah, it's barely changing. So the answer is a 1.2. But if I did like a 1.8 here, then we would actually keep seeing more of a change each time. But since I picked a 1.2 that was closer, then it was really close to the number, and it just had very little change each one. Okay, this is what Newton's method does. Okay, it's actually just trying to find the 0.
Jeez.
So, you guys mad at me yet?
No.
Okay. All right, don't forget to like, subscribe.